Welcome to the Ricky Matthews Show from the Citizens Bank studio, and I hope you're having a great day. I want to thank you, as I typically do, for all the great feedback. Our numbers continue to look good. People come to this show because they really want to celebrate what it takes to make a state like Mississippi tick. Now, listen, I love the fact that the show on Thursdays is actually rolled out to the Jackson metro area and the Mississippi Delta as well. We'll be rolling out to more markets and more days as we go forward, because it gives me an opportunity to tell the coastal Mississippi story to the rest of the state. And also it gives us an opportunity to grab some of the people that are doing amazing things in other parts of the state and introduce them to you here in coastal Mississippi. One of the things I talk about on this show all the time is that Mississippi is coastal Mississippi is an important economic engine for the rest of the state. So you got Chevron and Ingalls on one side and all the supporting industries. You have Stennis Space Center and the blue chip industries that are part of that. And between, you've got gaming and hospitality. You know, when we put it all together, it's really, really important for this entire region to hit on all cylinders all the time. And by the way, if we're not innovating, if we're not bringing new partners in, if we're not doing new things, then the moment we start to stand still is the day we go backwards. And you know what? If you want to talk about Stennis, if you want to talk about innovation, you can't have a conversation like that in coastal Mississippi without talking to someone at Stennis. So I'm thrilled to have back on this show Rodney McKellip, who is the associate director at Stennis Space Center. And we checked, the last time he was on the show was back in 2021. And you've been busy since then, haven't you, Rodney?
We have been busy. It's a crazy time down here at Mississippi's NASA Field Center. You know, Mississippi's in a select club that they need to appreciate. There are only 8 states that have a field center for NASA in them. And so it's exclusive club, and it's a club that all Mississippians need to realize the importance of, because we can't go to the moon, we can't go on to Mars without first going through Mississippi. Think of it as the 3 M's. I just came up with that.
But hey, you know what? It's so true. I say this a lot. I'll mention it when I'm with Ann as well, that the reality is the leaders 63 years ago who created that center, they were incredibly visionary, because you think about the buffer zone they created. You know, when we had the base realignment and closure committees that were happening, we talked a lot about encroachment. We worried about Keesler. We worried about when casinos were built in coastal Mississippi, would it encroach on Keesler's mission? And we had a lot of community conversations about that. We worried about the CB base, the Naval Construction Battalion Center. We came to appreciate as a community that the roles those bases played, not only in America's mission, but also the roles they played to help be part of the economic engine of coastal Mississippi, was really important. Oftentimes, though, we forget the role that Stennis plays in all of that. And the fact that our forefathers had this incredible vision to create that buffer zone around the testing facility so we could limit encroachment. Man, think about the scope of that place. The vision that created that was smart as hell back in those days, wasn't it?
It was, and it's paid big dividends innumerable times since then with, because what we do, testing rockets, makes a lot of noise. And we're so busy right now, we're testing rockets, 12, 14 hours a day. So it's not just an 8 to 5 job anymore. It can happen after hours when people are home a lot. And so having that 125,000 acres around Stennis that's uninhabited really keeps the mission going. It's probably the second to the test stands themselves. It's the most critical feature of Stennis Space Center that allows us to do our mission, because we don't have to worry about encroachment from development. And we've actually had organizations and tenants come to Stennis because the places that they were at before were experiencing encroachment, and they needed a place where they could do their mission effectively and not bother their neighbors. And that place is Stennis Space Center.
Yeah, think about 125,000 acres. Think of the kind of thinking that went behind that. It's, you know what it reminds me of? When you go to the Smoky Mountains and you see some of those small towns that became part of the Smoky Mountains National Park, when we were creating national park systems in America, the decisions that in some cases displaced people, in some cases said, you know, if you own property here, we're gonna somehow compensate you for that property. But tough decisions have to be made when you do something like this, and you have to do it in a way that's part of some big mission. And man, the mission was always clear as it related to NASA, wasn't it?
It was, and you know, it's NASA owes a lifelong debt of gratitude to the families that gave up their homesteads, gave up their land to allow NASA to move into Hancock County, Mississippi. I mean, look, it's 2024. In the 60s, east of the Mississippi, but you couldn't find 125,000 acres to sort of carve out of the eastern United States. So it's truly a unique feature. And, you know, let's not shortchange the role of our namesake senator, who was really the key integration point between the families and NASA to explain to them why it was important and the dividends that giving up this land in Hancock County would have for the state and the coast for decades to come. And it's come to fruition. We've been now 6 decades of testing out in the woods of Hancock County.
Well, you've got this the NASA mission testing rocket stages and engines. You've got the commercial side that is booming. So I bet in their wildest imagination, they never thought that space flight would become commercial. I'm saying in the early days. And look what's happened with the level of innovation that's taking place today. And the fact that you have the NASA mission and the commercial mission sort of peacefully coexisting, taking advantage of this great facility. When you have a situation like that, man, there is no rest for the weary. There's always something going on, isn't there?
There is. And you know, the commercial testing activities at Stennis are probably the biggest growth area we've seen in the past 3 or 4 years, and the period of biggest growth in the country as well. And so, you know, one of the things that we've figured out, and that these new aerospace companies has figured out, is Mississippi is a place where they can do business, and Stennis is a place where they can do business. And we've executed a number of really important partnerships with several of these up and coming aerospace companies that they're making a large investment either to utilize test stands that we have that we no longer have use for, or we lease them land and they build an entirely new set of test stands out there to do their own mission. So we're really turning into, much like you see at Kennedy, launching not just for NASA, but launching for everyone. It's the multi-user launch complex. We are evolving in that analogy in Mississippi to be the multi-user test complex with the likes of Relativity Space and Rocket Lab. And we've got a new partner that we just signed up called Evolution Space, which for Mississippi is a great story. It's a gentleman who had aerospace ambitions, native to Mississippi, left the area, became an aerospace leader and started his own company building solid rockets, and now wants to move that company back to his home state and back to Stennis Space Center. So the latest in a long line of successful commercial testing operations that we have going on at Stennis, which really drives it to truly a 7-day-a-week, 14, 16-hour-a-day operation down here.
That's incredible. Rodney, I was on my phone the other day. As a former media CEO, I have a lot of news sites I go to and whatever. But I was on X, and one of the things I sign up for on X is for anytime anything's happening with SpaceX, I want to see what's going on. So I'll immediately get sort of a note that says happening live at this moment. So I get the same kind of notes from NASA. And it's in this case though, what it was, they had launched. And they had cameras everywhere, cameras on the launch, cameras on when the stage comes back and lands. So, it's cameras in space, and the digital quality of what you're being able to watch live, all these different pieces happening through their control room simultaneously. Man, have we come a long way, man. The innovation that's happening right now in space is beyond anything we could have ever imagined.
Yeah, and that innovation is happening at Stennis. Funny that you mentioned SpaceX and launches, because on Monday, just 2 days ago, SpaceX launched a Falcon rocket that had a number of small sats on it, including the first one that Stennis Space Center ever worked on. We have a partnership with a company called Sidus Space, and they built LizzieSat-1, which we call LS-1. And on that small satellite, there's a payload that we designed called Astra, which the purpose of that is to demonstrate that satellites can operate autonomously without having constant input from mission control. And it's a growth area that we have at Stennis. We call it autonomous systems. And it's a fascinating way to automate a lot of operations. We started it for our test campaign, but now it's grown to take over the entire business. So we're really excited. Stennis and Mississippi got their first satellite in orbit on Monday.
Hey, yeah, I actually want to talk a little bit more about autonomous systems. How did that evolution occur? What kind of companies are involved in it? We'll hear more about that when we come back on the other side with the Associate Director at Stennis Space Center in Hancock County, Rodney McKellip. We'll see you after this break.
Great, thanks.
Welcome back to the Ricky Matthews Show from the Citizens Bank Studio. And every opportunity we get to talk about Stennis Space Center, we're gonna grab it, and we're gonna do more of it. I've had the opportunity back a few years ago to have Rodney McKellip, who's an associate director of the center, with us. He's a terrific communicator, and there's so much amazing stuff that's happening at this bookend of coastal Mississippi. Really, this bookend from Mississippi. Really, this bookend for America. I mean, what's happening at Stennis Space Center? A lot of what you see in space today doesn't happen if Stennis doesn't play its role. When we went to the break, though, we were talking about sort of this impressive milestone around autonomous systems. So, Rodney, why don't you give us a little bit more about that, this whole notion of autonomous systems, and you talked about the milestone, but there's a lot of activity in this area, and this is a growth opportunity for Stennis Space Center. So tell me a little bit more about that.
Yeah, you're right. It's an incredible growth area for Stennis, and an area of expertise that's really exploding across the entirety of the space industry. And for us to get a sustained presence around in lunar orbit and on the moon surface, we're going to have a lot of things that operate autonomously that don't need constant care and feeding by folks on the ground. And that's even more important when we go to Mars. And the communication delay between the moon and the Earth is minimal, and so you can do real-time conversations. The communication delay between Mars and the Earth is not minimal, and so you need to have systems in place that can monitor, detect, predict, and have and make decisions on how to execute corrections, all without having to wait for that delay, without having the person in the loop. It's something that sort of grew organically out of our need to automate a number of functions in our test complex. We deal with a lot of very high pressure gases that we distribute across the site. And it's a fairly dangerous environment to work in. And so we were thinking, is there a better way to do that than to do it all manually with folks, with engineers? And so we started working on, well, we could automate this, we could automate that, and it sort of grew into a whole functioning section where we moved on from automating our test complex functions to finding ways that we could demonstrate that same level of automation in other space applications. We mentioned the LizzieSat, which is sort of autonomous operations of a spacecraft itself. We've also partnered with JSC, Johnson Space Center in Houston, to look at how we can automate some of the functions of the spacesuit, so that the spacesuit can the spacesuit knows what the astronaut is going to do, what his tasks are for the day, say if you're on the lunar surface, and can monitor all the information coming from both the astronaut and the suit to make sure at all times, hey, do we have enough supply left, air, water, all those things to complete the mission? And if not, it can go in and make adjustments to say, all right, we need to cut this part of the mission short, but we should still be okay here. It's those kind of autonomous systems that are going to be the bread and butter of a lot of the long-term lunar habitat, and will be absolutely critical when we venture farther away from the planet and go to a place like Mars, where we have that constant transmission delay, and we've got to be able to do things in real time.
That's so. Again, you can put that underneath the heading of innovation, and you go back to from the very first days of NASA. NASA and their process to fix things and correct problems and be challenged with how we're going to handle this and how we're going to handle that. They ended up developing capabilities that have impacted the world way outside of NASA. Just when you put smart people together, there's really no way that the world's not going to be touched by their work. I mean, that's just the reality of it, isn't it, Rodney?
It is, and I think we're going to see as NASA and all of its partners, because we're not going to the moon alone. We're not certainly not going to be able to go to Mars alone. So we're sort of working collaboratively as a domestic space industry to get back to these places. But sorry, I lost my train of thought. What was your question again?
No, it's just the kind of innovation that's taking place, and
yeah.
The
So I guess what I was going to say is I think we're going to enter into this new era because of fast-paced innovation. Because we have to. We can get to the lunar surface. We've done that before. We know what it takes. We're on our way. We're going to launch the first crewed mission to the lunar orbit next year. But what we don't know is what does it take to live longer term outside of the environment of the space station? What does it take to live long term on the surface of another planet? And I think those requirements, that's one of the reasons why we're going to the moon first, right? It's close by relatively. And we can try out, we can have like test beds there of technologies that we eventually want to deploy farther out, let's say in Mars. And, we can work through all of that. And I think the result of that is going to be this tremendous uptick in cool new technologies because we need them to go beyond low Earth orbit and the moon. And so it's time to really get busy and start to develop those.
The kind of smart people that you put together that come in there through NASA, that come in there through the commercial partners and other innovative companies that are starting, when they start to collaborate with one another, there's some serious brain power there, isn't there?
It's a real synergistic effect, right?
It really is. So, we mentioned this earlier, but the 63rd anniversary coming up is amazing. In some ways, it seems young. 63 is kind of young in the scheme of things, but I guess when you're thinking about space, it's not so young. But it is an opportunity to look back and say, gosh, aren't we lucky to have this center and look what the center has accomplished during these 63 years. But it also is an opportunity to look to the future. And, you're sort of you're detailing a lot of that just in the midst of the conversation. But there's going to be a lot to focus on in the future, isn't there?
There is. And our focus right now is on testing new engines for the Space Launch System, the SLS, which you'll see over my shoulder there. So the first 4 Artemis missions, I think we talked about this before, are utilizing retired space shuttle engines. It's an engine that's made by Aerojet Rocketdyne, the RS-25 engine. And so all the engines that you see fly on Artemis 1 through 4 have been flown in space before. They flew on the shuttle, some of them multiple times. So we've had them in storage. We're using them again in Artemis. But the exciting thing now is we're going to run out of space shuttle engines, and we're going to have to start building new RS-25 engines. And that's really our focus now, is in the development process for the new and improved supercharged RS-25 engine, because some of those technologies are 4 decades old themselves. So there's a lot of better functionality that we can provide in the system that is the rocket engine now. So really what we're focusing on now, and one of our big test stands, are these development certification campaigns where we'll run an engine in a test stand. We have one going off in about an hour and a half. That'll run for 10 minutes, 600 seconds to test out the new features and make sure that these new engines are just as reliable, just as powerful as the ones that flew on shuttle for 40 years. We're also working on the new upper stage on the B stand, where we tested the core stage. We're going to be testing next year the new upper stage, which will provide us even more capability, because we have to bring a lot of stuff to the lunar surface. And so stuff takes a lot of trips. And so we're trying to maximize how much payload we can bring on this SLS rocket. And to do that, we need a better second stage. And so that stage, much like the core stage, is going to be arriving by barge here, barged up to the B test stand on the corner. And we're going to set it up to test just like we tested the first stage, only now we'll be testing a much smaller second stage. Those are the two big items we have coming up in the next 2 years.
Yeah. So the thinking behind the Artemis is the reality that it's going to be carrying significant payload. Is that kind of the bottom line?
It is, and we tested it in the same test stand as we tested the old Saturn in the 60s. The reason that Stennis was made to test the Saturn rocket series, and it's so big we had to add structure to the top of the B stand because it stuck out too far. So it's a massive rocket. But we need massive rockets to get the stuff that we need to lunar orbit, and then that's also going to be a flagship of when we go beyond lunar orbit toward Mars and beyond. We need to be able to bring a lot of stuff with us, so we need a very powerful rocket.
So when you guys look at, say, the old space shuttle engines that you guys have sort of recrafted, and compared to sort of, let's say, a SpaceX that most everyone is familiar with, because you're seeing those going up a lot these days, how different are those engines?
Well, it's there's an old saying around here that to some degree physics is physics. So the basic design of a rocket engine is largely the same, but there are key sort of distinctions to the architecture. One of them is fuel. So NASA's SLS uses liquid hydrogen, liquid oxygen. A lot of the new space companies have moved away from oxygen and hydrogen to go with oxygen and methane or liquid natural gas to give them a little bit different set of parameters for launch. The other thing that's unique about SpaceX, if you look at their rocket, is they go with a bunch of little engines. So they have 27, I think, of these Falcon engines on the bottom, whereas the NASA architecture is fewer, bigger engines. So, there's more redundancy in that system, but I think ours has demonstrated for 40 years that, it's a pretty good system as well. But there's more than one way to get to space.
Rodney McKellip, who is the Associate Director of Stennis Space Center. Next time we get together, we'll talk about how people can learn more, and we'll get the latest. But we'll catch up with you more often. We're not going to wait 3 years to get back together again, Rodney.
I hear you, Ricky. It's always a pleasure to be on your show and talk to the great people of Mississippi about the things that are happening in Hancock County.
You bet. It's been a pleasure. Listen, have a great day, and we will see you tomorrow.
Thanks, Ricky, and go Artemis.